We touched very quickly on how Twitter does their background images so that the background image does not move with the page. This time we're going to cover how they make every background image spread over the entire page, no matter how big or small the image actually is, and it doesn't matter how big or small your browser or your screen resolution is. So the property is background-size, and it accepts 4 different answers. First is a width by height pixel value, or a width by height percent value, or contain or cover. So width by height pixel value are 2 values together. So you'd use 10 pixels by 10 pixels. It doesn't have to be the same. It could be 10 pixels by 50 pixels. Same thing with percent. 2 values are put together, like 10% and 10%. Again, that could be 10% and, 90%. The thing with width by height percent, it is the percent of the element that is representing. So if you have an element that is 50 pixels wide and 50 pixels high, and you wrote 200% by 200%, then your image is going to be twice as big as that element. 200% or 2 times larger. Except we don't write 2 times larger, we just write 200%. Contain will scale the image so that the entire background image will fit inside the element. No matter how big or small the element is, the background image will always show itself. Where cover will spread the image so that it takes up the entire background of the element. So long as we're setting background image, background P, and background position, etc., we can now set its size. So let's look at width by height in pixels. We can set a background size to be 10 pixels wide and 10 pixels tall, even if the background is different. Well, in our example, we're actually going to use 40 by 40, and let's take a look at this. We have the small class. Background image is just our star.png. We've used this before. Our background size is 40 pixels. 40 pixels. Remember, width by height, or x-axis, y-axis. We set the background repeat to no repeat so it doesn't keep showing the star image. I gave it a 1 pixel solid red border, and that's just so that you can see where the image is in proportion to the element, and a width and height of 50 pixels. So what we did was we changed the background image size. Originally it is 15 by 15 pixels, but the star in here is now 40 pixels by 40 pixels. And it doesn't take up the entire element, as the element is 50 pixels by 50 pixels. So we have this space right along here, along the right column and the bottom row. Alternatively, we can use a width by height in percent instead of pixels. A percent will be the percent of the element that is representing, or its parent element. It can be smaller, it can be larger, both work. In this example, we're going to make the star larger. So we just have a big class, same background image, no repeat, 1 pixel solid red border, width and height are 50 pixels, but our background size is now 200% and 200%. Before we used 40 pixels, now we're using 200%. And this is how it displays. You see the top left corner of our background image, and that's because the background image is now 200% larger than the element, which is equivalent to being 2 times larger than the parent element. So you're only going to see half of the width and half of the height of it, which will give us our top left corner. Next we have contain. So instead of using 100% width and 100% height to cover an element, we can use contain or cover. We'll cover contain first. Contain will always show the background image no matter what the size of its parent element is. Here are some examples to show you how contain will change when its parent element changes. We have contain1 is our class name. Again, we're going to use a star image. Background size is contain, no repeat, width and height are 50 pixels, with a 1 pixel solid red border, and that's just so you can see the element. So when we use contain, the background image is going to show its entire image no matter what the element size is. If we take a look at our second example, which is contain2, all we did was change the element width to 25, and it also made our background image smaller. And this is what I mean by the parent element changing. No matter what the element size is, the background image will always show the entire image. Now if we change this width to, let's say, 10 pixels, our background image is going to get even smaller. The similarity between these two examples is that in both examples, the star image is completely showing itself. Now that's different from cover. Cover will expand or contract the background image so that it covers the entire element, but it will not adjust itself to fit in the element like contain did. Now here are examples to show you how cover will act. Again, we have our image, no repeat, our border, width and height of 50 pixels. We change the background size to cover, and as you see, the image expanded itself so that it fits both horizontally and vertically into our element. Now what if our element isn't a very good size and it doesn't cooperate with the background image's size? Well, that's what happens when we get Our second example, we have the cover2 class. The only thing we changed here was the width. We half-lifed the width to 25 pixels. The background image is the exact same size, even though we changed the width to 25 pixels from 50 pixels. The reason it does that is because the browser will always try to keep the background image proportional when it uses cover, and in doing so, it had to expand its height so that it would fit the entire element, but it also had to expand the width. When the image stays proportional, but the element isn't in proportion with the background image, then you're going to get this, where it's cut off. Now these are very useful when you want to create a background that will fit in the element perfectly. With background size, there's no need to adjust or edit your image or images to fit the element or elements. And the images will expand or contract in every HTML5 and CSS3 browser, so you know that the background image will appear the same in every browser for every user. And it's just one thing you have to look out for when you're using this, and that's when you're expanding an image. You notice how we expanded the image to 200% by 200% up here? And our image starts to get pretty blurry. Well, that's because when you expand an image, you're blowing it up, you're getting closer to it. It's like when you put your hand closer to your face, and your hand starts to get blurry. The exact same thing is going to apply with your image. And just the opposite, if you have a very large image and you shrink it down to, let's say, 10% by 10%, then your image should look a lot sharper, but that also depends on the image as well. That's just something to keep an eye out for, and a little bit of a heads up in case this becomes a problem for you.